the first, so the nth term is equal to 1 over 12 times, and the common ratio is 1.2 to the power of n minus 1. But we already decided that there were alternative descriptions of these. That was, instead of saying the first, second, third, fourth, we could say the 15th, 16th, 17th, 18th kilometre. We've been given a name for that, and that name is UR. And we already decided before that R was equal to N plus 14. So therefore, UR equals a 12th times so N equals 14 minus R. So therefore 1.2 times to the power of 14 minus R minus 1. So UR equals 1 over 12 times 1.2 to the power of 13 minus R. Now that is not what we're being asked to show. We want to show that UR is equal to 1 over 12 times 1.2 R minus 15. So what's gone wrong? These are definitely different. Just reading the question carefully again. So the time taken to complete the rth kilometre is UR hours. So the 18th is U18. So oh, okay, it's just straight out of this. There's algebra mistake there. So it's not 14 minus R, it's R minus 14. So that's R minus 15. Okay, so therefore we're done. Okay, sorry about that. Okay, so that's part B. So what I did in part B was I needed to produce some algebra. You can produce some algebra yourself if you want, using naming, stating, and equating. Just state a fact using equal sign, but use names for the things that you're talking about. Or, and this is what I did here, just borrow some machinery. These are some formulas. So state a fact using these, and then transfer the names of these into the names of what you've been given. So that's what I did here. I had the names for the terms. That's the N in the classic formula. But what I was really interested in is the names for the kilometres, and I just converted one to the other using this little conversion. That's a very classic strategy in this chapter. Now, question number C, part C, is using B, or we can use an independent method if we like. Find the time taken to the nearest minute that she takes to complete the race. Okay, the time she takes to complete the race is these added up plus the time taken for 14 hours. But what I'm going to do instead is I'm going to add these up and then add the time I already know. Oh, wait on. I've already got a time for the first 16, and that's 1 hour and 21 minutes. So I'm going to work out what these added up would be. Now, how many of those are there in the race? If it's 25 kilometers, 25 minus 17 is 8. But let's just check if that would give the right answer for the number of terms there. If it was an 18-kilometer race, this is an example I always check out my method on small examples. If it was 18, then 18 minus 17 would be 1, so I need to add 1 to get the actual number of terms. So the number of terms remaining there is 25 minus 17, which is 8 plus 1. So there's 9 terms. That's a geometric sequence. The first term is 1.2 squared over 12. The common ratio is 1.2. The number of terms, as I just decided, was 9. So therefore, the answer is S9 equals 1.2 squared over 12, 1.2 to the power of 9 minus 1, all over 1.2 minus 1. So you pump that through a calculator, you get 1.44 divided by 12. So that's 3 over 25 times 1.2 to the power of 9 minus 1 all over 0.2. So 3 over 25 times 1.2 to the power of 9 minus 1 in a bracket equals divided by 0.2. So the time taken is 2.4958 etc. hours. So what is that in minutes? So we've got roughly half an hour, but doing that exactly would be 29.75 minutes. I just times that decimal by 60, and I got 27 minutes. So the final time is this number of hours plus this number of hours, that's 3 hours, and then this number of minutes plus this number of minutes. It's set to the nearest minute, so it's 3 hours and 51 minutes. Hope and pray I get that right. In the back of the course is wrong, but a teacher who Miss Fell has corrected this. It's 3 hours 51 minutes, as I said. This demonstrates just how careful you have to be in time questions. It's very tempting to look at that, like 3.2 hours, and think, or even like this, 3.25 hours. And think that's 3 hours and 25 minutes. It's not. It's 3 whole hours plus a quarter of an hour. A quarter of an hour is 15 minutes. That's 3 hours, 15 minutes. Be very careful with that. Now this problem also demonstrates that you get to decide what you want to be the sequence in order to save time for yourself. Since in part A I'd already worked out what all those added up to, I got to choose that would be my geometric sequence. I don't think that's what it suggested. It said hence such and such, so maybe it had some other idea. But that was I consider that to be the most convenient strategy. Okay, question number 14. Liquid's kept in a barrel. The start of a year, the barrel is filled with 160 litres of liquid, but it evaporates, and over the course of a year, it gets reduced by 15%. Now, when I say over the course of a year, my wording is deliberate. I don't think that nature's processors wait a whole year before suddenly reducing it by 15%. So this is not like money in the bank. When you put money in the bank, they do wait a whole year. Well, most institutions, they do wait a whole year before they add the money in. So that's why in questions about money in the bank, I often very carefully lay out a sequence of start of the year, end of the year, start of the year, end of the year. I don't think I have to do that here because the process of evaporation is continuous over the course of the year. Now, we get to decide what sequence we want it to be. I'm just going to lay out some figures first. So it's the start of year 1, it's got 160. End year 1, it's got 160 times 0.85. End year 2, it's got 160 times 0.85 again. And end year 3, it's 160 times 0.85 to the power of 3. Okay, so it looks like the best choice of a sequence would be that. Just first, second, third, fourth. But I could understand why you would not dig that. It's because it's not always the case, if that's my sequence, that the heading requires simply a 1 to be added to get the position. That's generally true. 3 becomes a 4, 2 becomes a 3, 1 becomes a 2. But at the start, that's not the case. So we might want to simply regard that as the sequence. It's completely up to you. If that's the case, then the sequence will need to be this, and that will just be a miscellaneous separate term that has to be taken into account later when I'm actually answering the question. Okay, so now I'm in the groove. I've written out the terms of the sequence. So these three and then this miscellaneous one. Part A, calculate the amount of liquid in the barrel at the end of the first year. That's 160 times 0.85. We've already done that. So 136 litres. Show the amount of liquid in the barrel at the end of 10 years is approximately equal to 31.5 litres. So at the end of 10 years, we'd have, this would literally say end year 10. So we would be at the 10th term because this number always matches this. So I'm going to use this formula for the term after the nth term. So it's 160 times 0.85, that's my A, times 0.85 to the power of 10 minus 1. So it's 160 times 0.85 to the power of 10, which you pump that through a calculator. Which is 31.499, which is 31.5 litres to 1 decimal place. Okay. Now, at the start of each year, a new barrel is filled with 160 litres of salt, so that at the end of 20 years, there are 20 barrels containing, I don't know why I said salt. At the start of each year, a new barrel is filled with 160 litres of liquid, so that at the end of 20 years, there are 20 barrels containing liquid. Calculate the total amount of liquid to the nearest litre in the barrels at the end of 20 years. Okay, so right, well, I'm going to have to be very careful with this. So let's have the years along here. And the barrels down here. So our first barrel, that is at the end of 1 year, so after the first year, it's 160 times 0.85. We discovered that up here. After 2 years, it's 160 times 0.85 squared. After 3 years, it's 160 times 0.85 cubed, etc., etc., etc. This heading matches the power, so I can therefore say that after the 20th year, it'll be 160 times 0.85 to the power of 20. Now, barrel number 2, that gets put in at the end of this. That gets put in at the end of the first year, so it's at the end of the second year that it's been reduced by 15%. This, by the way, is why we encourage you to do percentage change with decimal multipliers when you're at GCSE. Okay, so at the end of the third year, it's going to be 160 times 0.85 squared, and then at the end of the fourth year, it's going to be 1.085 to the power of 3. Oh, sorry, to the power of 3. So at the end of the 20th year, it'll be this. Now, the third barrel, it's 160 times 0.85 for the first time in the third year. At the end of the fourth year, it's had 2 hits. So that and that are 2 different from each other. Versus the 1, the 4 versus the 2. So when I put a heading for the 20th year, there'll be an 18 there. Now I've got into the groove now. I think I can work out the pattern. Therefore, if it's the 20th barrel, so how does this number always compare to that number? It's it's 21, so 20 plus 1 minus this. So let's just check that works. Take this number. So take the number 20. Add 1, you get 21. Take away 2, you get 19. Take 20, add 1, get 21. Take away this, you get 18. So therefore, my 20th row, in other words, the 20th barrel, so take the number 20, add 1, get 21, take away this number, get 1. So these are all the amounts in all the barrels. And this is a classic example of how you get to decide what the sequence is. There's loads of sequence. There's this sequence, there's this sequence, there's this sequence down the diagonals, whatever you want, right? But the thing that actually answers the question is this sequence here which I've constructed. That's a geometric sequence. The first term reading it upwards is 160 times 0.85. The R is 0.85 clearly, and the N is clearly 20 because I laid down 20 rows. I was very careful about that. You need to be really, really careful with deciding what your N is. So you pump that in the adding up formula. So that's the A. This is the bracket with the R to the power of N. There's the minus 1 all over the R minus 1. Pump that through a calculator with great care, and you get the answer.